In this video, we are going to talk about queues in data structure. See, what is a data structure? It is a way of storing and organizing the data, right? We have discussed few data structures like arrays, linked list and stacks. In this video, we will see what is queue. So, queue is what? It is a linear data structure, you can say, or you can say queue is an abstract data type. In this video, we will discuss queue as an abstract data type. ADT means, when I say ADT, it means we are going to define, we are going to see the features or operations of queue. We will not go in detailed implementation, right? See, we can implement queues using arrays, linked list as well as using stack. That implementation we will discuss in next video. In this video, we will see what is queue and what are different operations performed on queue, fundamental operations, fine. As well as we will see some applications of queues. So, let us understand this concept with a real life scenario first of all, right. Let us suppose there is a ticket counter, fine, it is a movie ticket counter you can consider, right, and now there is no one there in the queue or in the line, fine. First of all, suppose you go and you stand there, and after that second, third, fourth, fifth, 5 persons are there. So, obviously, if you are the first, then you will get the ticket first, then you will go, after that second person, then third, then fourth and then fifth. And suppose before you there are 5 persons and after that you reach there. So, you will have to stand at 6th position, right, and you will get ticket after these 5 persons, fine. So, here the simple funda is what? First in, first out, or you can say first come, first serve. The person who is first in the row will get the ticket first, right. So, now in the queue, this funda is known as first in, first out, FIFO. So, queue is basically what? It is a structure, or you can say it is an ordered list. As stack we have discussed, stack is an ordered list that follow the principle of LIFO, last in, first out. Queue is a collection or queue is an ordered list which follow what principle? First in, first out, right. Now, what is that principle? See, you can say queue is a structure that is going to follow some restrictions on insertion and deletion operation, fine, or that is going to follow a rule, that is going to follow a principle. And what is that rule? Insertion and deletion. In case of queue, insertion would be performed from one end, right, and the name of that end is known as rear or tail, right, and deletion would be performed from another end, and that end is known as head, or you can say front, right. In queue, if you say more technically, then we will use rear and front, not head and tail. And rather than insertion means adding a data in the queue, fine. So, the technical name in the context of queue, it is known as Enqueue, right, and deletion is known as dequeue, fine. And in stack, this insertion and deletion is known as push and pop, fine. So, enqueue operations would be performed from one end and dequeue operation would be performed from another end, right. So, we will see the logical representation of queue. If you logically represent the queue, it means it will have 2 ends, 2 open end, right. In stack, we have only one end, one open end, like, and queue would be represented something like this. It is having 2 ends, one is this, one is this, right. Suppose I am taking this end is rear, right, and this is what? Front. Obviously, when you are going to implement this queue, you will have to take front and rear, 2 variables, like that is must. So, insertion, or you can see enqueue operation would be performed from rear. From here we can insert data in the queue, And if you want to delete data from the queue, it means from the front we can dequeue. We can delete data, right? So this is what logical representation of a queue. Fine. Suppose in queue I have right now 2 elements, 2 and 3 at some point of time, right? So at that time this front variable would be pointing to here and the rear variable would be pointing to here, right? And the index is suppose 0 and 1 now. At some point of time, suppose we are implementing this queue using array, and at some point of time we have only 2 elements in that queue and index is 0 and 1. So front is 0 and rear is 1. Now in this case, if you want to insert third element, from where we can insert? From this end only. So what you need to do? If suppose the size of this queue we have taken 5, we can insert 5 elements, the capacity is 5, right? So now first of all you will increment this rear, right? So now rear plus plus, that is rear would be pointing to this node, and now you can insert another data. Suppose I have inserted 5, right? And if you want to delete, then from here only you can delete, right? So first in, first out. Firstly we have inserted 2 and that is the first element you can delete. If suppose you want to delete this 5, you cannot directly delete this 5. First of all you will have to delete this 2 from the queue, then 3 from the queue. After that only you can delete this 5, right? So that is why it is known as, it will follow FIFO principle, first in, first out, or you can say last in, last out. Last in, last out. Somewhere it is also written like this. That is same thing. Last integer that is enqueued in this queue is 5, and that would be the last element you can remove. So last in, last out. This is queue. So now we will see some operation that can be performed on a queue. So you can define queue as it is a ordered list, or you can say it is a collection in which insertion can be performed from one end, that is from rear end, and deletion can be performed from another end, that is from front end of the queue. Fine. And it is going to follow, it is a structure you can say that is going to follow the FIFO rule, that is first in, first out, right? So now we will see some operation that can be performed on queue. So 2 operations we have discussed, that is first is enqueue and that is second is dequeue, right? These are 2 fundamental operations, enqueue and dequeue. Enqueue means inserting or adding a data in the queue, dequeue means deleting a data from the queue. See here in enqueue I am passing 2 as an argument, because I want to, suppose I want to insert 2 in the queue, then I can pass this in the enqueue. In dequeue no need to pass anything, because always the element would be dequeued from the front. So the element which is at the front index of the queue, that would be deleted, right? So no need to pass anything. Third may be front, or you can say peak. In stack it was top. It means the motto of this operation is what? It is going to tell you what is the element at the front of the queue, right? We will see what is the element at the front of the queue without removing that element from the queue, or without dequeuing that element from the queue, right? Now is queue full? You can check by is full function. It will return true if the queue is full, otherwise it will return false. Is empty? Same we have discussed in stack. If the queue is empty, then it would return true, otherwise it would return false, right? Now see the logical representation of queue. So this is the logical representation of queue. Fine. Any end you can take, front or rear, but you have to take care of that thing, deletion from front and insertion from rear, right? So here I am taking, this is what front and this is what rear. I will insert always from here, delete from here. You can take front this side, rear this side, as you wish, but insertion and deletion would be according to the rule only. Fine. Now if you want to insert some data here, obviously you need to specify the size of this queue. Suppose the capacity of queue is 5. You can say size I am taking is 5. how we will take the size 5, how we will implement this queue, that thing we will discuss in next video. So it means I can insert 5 element in this queue, right? Here I have this end, and index is 0, 1, 2, 3 and 4. So initially there is nothing in the queue, right? In that case what we will do, both front and this rear would point to -1. Hypothetically we assume that there is a -1 index and these are pointing to -1. It means queue is empty, right? That is the signal. If this is -1, it means queue is empty. Now I want to enqueue 2. Now what would happen? See, front is -1, rear is also -1. Obviously we will increase front and rear both. So front plus plus and rear plus plus also, right? So now front is also pointing to here, and at this point of time rear is also pointing to here at 0, and now we can insert here 2, right? Now suppose again I want to enqueue 3. I have called again a function enqueue, and suppose 10 I want to insert. In that case what will happen? See, front will always point to this node, the front one, the front element. We will not move this front for inserting the data. Inserting would be always from the rear part. So the rear variable we are going to move. So first of all we will increase the rear plus plus means now rear is pointing to here, and now here I can insert 10. Again suppose I am calling enqueue -1. Again what? We will not touch this front, we will move this rear, insertion from rear only. That thing you have to take care. Rear plus plus means rear would point here, and now here I can insert -1. See, at this point of time front is 0 and rear is now 2, right? Now suppose I am calling dequeue function. No need to pass anything because always the data would be deleted from front. Now you can touch this front. Now we will not touch this rear. In dequeue we will touch this front, right? So now suppose you want to print the data you have dequeued. So you can write down printf, the data you have dequeued is from the queue. You can print this value, and after that what you will do? You will do front plus plus, right? So now front is pointing to here. Front is 1, rear is 2. Or in dequeue simply you will write front plus plus. That is also fine, because now this is not a part of queue. The part of queue is only 2 elements. Whatever between front and rear, that is part of queue. This is now a garbage value, and we don't care what garbage value lies here. In future if you will access this cell and if you will write here something, then this value would be overwritten. That is fine. Now suppose I am calling enqueue function 3 times. So now enqueue 0 means from rear I will not touch this front. From rear only I can insert rear plus plus. Rear would be pointing to here, and here I can insert 0. Enqueue 1, rear plus plus, here I can insert 1. Enqueue 5, then rear plus plus, but what? We have the size till here only. So if rear is what? Rear is equal to 4, it means rear is equal to this maximum size minus 1. Index is 4 now, maximum size is 5. In that case you will print, we cannot insert any data. It means you can say overflow condition. This is overflow condition, right? So this would print what? Overflow condition. This is now overflow condition, right? And what is underflow condition? Suppose you want to dequeue and there is nothing in this list, right? Both front and rear are -1. In that case what? That is an underflow condition. That is queue is empty, right? Now suppose before calling this dequeue function I am calling peak function after this enqueue, or you can say front. So it will return what? Front value is now 10, because see queue is between from front to rear, that is here to here. This is what garbage value. So I'll rub this one. This is garbage value, right? So now this will return 10. After that suppose you are calling dequeue function continuously 3 times. What would happen? First of all dequeue, it means front plus plus. Front would point here. Again dequeue front plus plus. Again dequeue front plus plus, right? Means front and rear both are pointing to here now. This is what a garbage value, this is not a queue. Suppose I am removing these value from here, from these cell, because we can overwrite these values, right? Now, as you can see, both front and rear are pointing to here. Both are at same index. So in dequeue you can write down one condition, you can check that condition also. If front and rear is equal, if front is equal to rear, in that case what? It means only one element is there in the queue. So what you can do after removing this, what would happen? Front and rear is equal to -1. You can set front and rear is equal to -1 because this is the condition we have set for empty queue, right? Or if you will not do this thing, then simply same procedure front plus plus, right? Front plus plus means front would point to here, that is 5, front becomes 5. So another condition of checking the empty queue is what? If front is greater than this rear, because rear is still 4, front is 5, right? In that case it means queue is empty. Front plus plus means we have deleted this queue, right? So, deleted this element from the queue, so it means queue is empty. So when front becomes greater than rear, then also it is empty. So we are going to see how to write down these conditions in next video. Fine. Now suppose if you talk about the time complexity, then in that case these operations would take order of 1 only, because we are not going to write any loops or anything for performing these operations. So it would take order of 1 only, right? Constant time. Now suppose at some point of time both front and rear are pointing to this node. It means queue is having only one data, this. These 4 cells are empty, right? And now if you call Enqueue, in that case it would return what? Queue is full. That is the drawback. Why it will return queue is full? Because see here rear is what? Pointing to 4, rear is 4, that is maximum size -1, and that is condition of what? Overflow condition, means the queue is full now. It will show you queue is full, right? But see, these spaces are free, but we cannot insert here. This is what wastage of the space. So this is drawback of this queue. We have a solution of this queue, that is the circular queue. That also we will discuss later. Fine. So but this is now a drawback. You have space, but you cannot insert here data, right? Now we will see some applications of queue. So the most common application of this queue data structure is what? It is used where you want to serve the request on a single shared resource. Suppose you have a single resource and that is shareable. Let us take you can take an example of printer. Suppose you have one printer and that is shareable. Fine. So what would happen? It's not like that. Suppose there are 5 PCs and these 5 PCs are sharing one printer. It's not like that. It will give command and this will print, and at the same time it will print, it will give command and it will print, right? What this printer will do, suppose this has given some command to print a data and now the printer is printing. Now at the same time computer, this 3, it has given command to this printer. Then what would happen? The printer is busy, na? So what printer will do? It will have a program, so that request would be stored in queue. After that, suppose this printer would give the request, so it would store here. After that this would store here. So it will, in the memory, in the printer memory, it will make a queue of all the request, right? First of all it will print whatever the request it has given, then it will fulfill request of 3, then 2, like this, right? And queues are also used in real life scenario, like you can take an example of when you call in customer care, then sometimes they tell you to hold on for few minutes because their representative is not free. So what they do, they use queues to put the people on hold, right, until their representative are free. Fine. Next you can take an example of processor. See, you have only one processor, CPU you can say, right? So the processes would be placed in queue. In operating system, I guess we have discussed many times when we were discussing the concept of operating system, then you can check out in the playlist. There are ready queue, there are waiting queue, fine. So the processes would be put in the queue, and as soon as processor gets free, it will take from the queue, it will take the processes from the queue one by one, right? So all the processes are also put in the queue, right? Because processor is what? It is a shareable resource. Any process, all the processes can share this processor, right? But obviously we cannot execute all the processes at the same time. So you have to put those processes in waiting, or you can say those processes are put in queues, right. So these are some examples, these are some applications of queue data structure, and there are many more applications of queue. We will discuss all these one by one in later videos. So in next video basically we will discuss how to implement queue using arrays and then using linked list and then using stacks. Fine. So I'll see you in the next video. Till then, bye bye, take care.